On the ACT math exam, you may be asked to identify a recursive expression for an arithmetic or a geometric sequence. So let's review recursive expressions. Recursive expressions are always going to give you the first term of a sequence as well as an equation to be able to determine any term based on knowing the previous term. So for example, I have a function a of n, and that function is defined as a of 1 is equal to k, which is the first term in a sequence, and then a of n is equal to a of n minus 1, meaning the previous term, plus d, the common difference. And that's a lot to unpack, so let's do an actual example. So let's define a recursive expression for the sequence 1, 3, 5, 7, 9. So we always start out with the first term. So a of 1 is equal to 1. Then we have the general part of the expression. So a of n is equal to a of n minus 1 plus 2, where 2 is the common difference. So we can use that expression to find, for example, the sixth term in the sequence, because we already know the fifth term is 9. So if we did that, we would say a of 6 is equal to a of 6 minus 1, or a of 5, plus the common difference, which is 2. So a of 6 minus 1, or a of 5, is equal to 9. So a of 6 would be a of 5 plus 2, which is 11. What about geometric sequences? Well, the recursive expression in a general sense for a geometric sequence can be defined as g of n, where g of 1 equals k, and k is the first term in the sequence. And in general, g of n is equal to g of n minus 1, also known as the previous term, times the common ratio r. So to make that more concrete, let's look at the recursive expression for the sequence 1, 2, 4, 8, 16. So again, we always have the first term defined for a recursive expression. So we have g of 1 is equal to 1. Then we move on to the general part of the expression. G of n is equal to g of n minus 1, or the previous term, times the common ratio, which in this case is 2. So again, if we wanted to find the sixth term, then we would simply use that bottom expression. So g of 6 is equal to g of 6 minus 1, so g of 5, which is 16, times the common ratio, 2. So we would get 32. All right, let's do a couple of sample problems. Write a recursive expression for a general term in a sequence where the first term in the sequence is 0, the third term in the sequence is 8, and the sixth term in the sequence is 20. All right, so it looks like based on this, we start at 0, and then by the third term we're at 8, and then the sixth term we're at 20. So it looks like this is an arithmetic sequence with a common difference of 4. And we know the first term is 0. So let's write this out. So we have a of 1 is equal to 0. And then in a general sense, we want a of n is equal to a of n minus 1 plus that common difference, which is 4. Now what about the next example? Write a recursive expression for a general term in a sequence where the second term of the sequence is 6, the third term in the sequence is 12, and the fifth term in the sequence is 48. Alright, so let's identify whether this is a geometric or an arithmetic sequence. So we're starting with the second term, 6, and we're moving to the third term, which is 12. If it were arithmetic, then we would have a common difference of 6. If it were geometric, it would be a common ratio of 2. So the fifth term is 48. So if we were to add 6 and 6 to 12, we would get the fifth term, so that would be 24, so that's wrong. But if we were to multiply 12 times 2 to get the fourth term, and by 2 again to get the fifth term, we would get 48. So this does look like a geometric sequence with a common ratio of 2. So we're given the second term. We need the first term to be able to define this recursively. So we know the common difference is 2. So that means we can just divide 6 by 2 to get the first term. So g of 1 is equal to 3. And then the general part of this recursive expression would be g of n is equal to g of n minus 1 times 2.